Hello student, now we are going to discuss the Prins reaction. So in Prins reaction, first we can call that it is a carbon-carbon electrophilic reaction. Carbon-carbon electrophilic reaction, right? So it is electrophilic carbon-carbon coupling reaction. We can call that electrophilic carbon-carbon coupling reaction. So in this reaction we have to take either aldehyde or ketone functionality with react with the alkene in presence of acid catalyst. So this is the electrophilic, right? It is a electrophilic substitution reaction and it gives two different product. One product might be 1,3-dioxane type material. This is known as dioxane, OO. So 1, 2 and 3, 1,3-dioxane type material. Here may be any of the group depending on your aldehyde and alkene, right? So it is electrophilic carbon-carbon coupling reaction between aldehyde and ketone with the alkene in presence of acid catalyst. So two product is possible. One is 1,3-dioxane and the second one is 1,3-diol. 1,3-diol. For example, here is OH and here is the OH. So 1, 2, 3. So this type material. Here may be R, here may be R. So it is different, right? So two product is possible, 1,3-dioxane and 1,3-diol. Out of these two product, this one is the major product and this one is the minor product, right? So 1,3-dioxane type material is the major in case of the Prins reaction. 1,3-diol type material is minor in case of the Prins reaction. So your starting material is aldehyde or ketone and another starting material is the alkene, which is catalyzed by the acid catalyst, right? So we can add H2SO4, HCl, any of the acid catalyst which can donate the H plus. Okay, now suppose we discuss the reaction part. Suppose we are taking the simple aldehyde group, this is the formaldehyde, and react with the alkene. Suppose this type of alkene is there, so it gives 1,3-dioxane type material at first, right? So here is the H, here is also H. This 2H comes from here. This 2H comes from the aldehyde part and this part comes from the alkene. This part comes from the alkene by using H plus, right? So you have to remember that if here is the R group, suppose here I am putting the phenyidine, so instead of this hydrogen we will get the phenyidine. If I am putting here something, suppose here I am add here R group, right? So I may get the R group over here. Clear? So this part is from the alkene and this two part is from the aldehyde group and this two oxygen is from here carbonyl group. So this is the 1,3-dioxane type material and it is major product. And the second product is like that, 1,3-diol, 1, 2 and 3, 1,3-diol. Now these are, so we can say that this part comes from the alkene and this part comes from the aldehyde group. So in short we can say that in case of the 1,3-dioxane type material, two carbonyl group is added and one alkene is used, while in case of the 1,3-diol, that is the minor product case, 1,3-diol product, one aldehyde and one alkene is used. So it is easy to memorize that this two part comes from the aldehyde, this part comes from the alkene, this part comes from the aldehyde or ketone, or this part comes from the alkene. Clear? So it is used when you are dealing with the application part. Let me discuss the mechanism. So here first we use the aldehyde group. Simply we can say that the formaldehyde. So in presence of H plus, so as we know that here oxygen is containing the lone pair, so this lone pair attack on H plus and now it is converted to OH. So this is positive charge. So as we know that the positive charge on oxygen is not stable, that's why it attract the bonding electron pair and it is converted to OH. And now this electron transport to oxygen, that's why this carbon is now positively charged, right? Now as we know that alkyne act as a electron rich species. Alkyne act as a electron rich species. That's why this carbon with their pi bonding electron attack on this carbon, right? So this pi bonding electron attack on this carbon. So you will get suppose R is here, R is attached with this 2 carbon, so this is 2 carbon. Now this carbon attached with here, this carbon attached, suppose this is star carbon, so this one is the star carbon. Now this star carbon containing 2 CH2 and 1 more OH. Clear? Okay, now I break this bond, so here is the negative charge, here is the positive. This negative charge attack on this carbon, that means R carbon nearer to R is positively charged, so this is the positively charged. So this is the intermediate. Now the possibility of 2 different products, that is 1,3-dioxane and 1,3-diol, is comes from this part. Suppose we are firstly moving towards the 1,3-diol type material. 1,3-diol type material. So if we add the water, molecule, now this lone pair of oxygen attack on this carbon. Why on this carbon? Because it is the positively charged. Here oxygen act as a nucleophile, this cation act as a electrophile. So R, this OH as it is, and now this water molecule attached with this carbon. So here O, H and H. So this oxygen is now positively charged. So as we discussed earlier that whatever we are going to add in the first step, it always liberate in the last step. So here removal of H plus. So this H plus remove from here to stabilize the oxygen. So R, here OH converted to OH, and this is OH. So we can say the 1, 2 and 3 diol. So 1,3-diol material is formed and this is the minor product, right? So this is the first case, or we can say that to generate the minor product. Now if we add more carbonyl group, aldehyde or ketone, so same mechanism is follow. Here oxygen also carry 2 lone pairs, which is attack on this electron deficient carbon. OH as it is, R as it is. Now this O attack with this carbon, so here O, now O is attached with the carbon and this carbon attached with the 2 hydrogen group. Clear? So this oxygen lone pair attack on this electron deficient carbon, this oxygen attached with the carbon, this oxygen attached with the carbon, and carbon attached with 2 hydrogen group. Now this oxygen is positively charged. Why? Because it is trivalent. This oxygen use his lone pair to attack. Clear? Okay, oxygen is not very stable, na? Oxygen is not very stable, that's why it attract the carbon oxygen bond pair. So this bond pair attract by the oxygen, so it is now converted to R, here O, this O is attached with the carbon and this carbon attached with the CH2, right? So this bond transfer to oxygen, that's why this carbon is now positively charged. Remaining part as it is 1, 2 carbon, this is 1 carbon, this is 2 carbon, 1, 2 carbon, and now it is attached with the OH. Clear? So now this carbon is positive charge and this oxygen having lone pair, so this lone pair attack on this carbon. Clear? This oxygen is electron rich, this carbon is electron deficient, and they are in closest vicinity, pass hi hai. That's why this oxygen lone pair attack on this carbon. So now it is converted to here O, these two carbon as it is, this carbon is attached with the oxygen, and now this oxygen attached with the CH2, CH2 attached with the oxygen. Clear? Now this contain the hydrogen. Now as we discussed that, यहाँ पे हमने H प्लस ऐड किया था, यहाँ पे हमें H प्लस निकालना है. सो रिमूवल ऑफ H प्लस. क्यों निकाल रहे? क्योंकि यहाँ पे ऑक्सीजन है वो पॉजिटिवली चार्ज है, क्योंकि इसके पास 3 वैलेंसी ऑक्यूपाई है, तो इसकी एक वैलेंसी को हमें फ्री करना पड़ेगा. क्लियर? सो रिमूवल ऑफ H प्लस एंड इट गिव्स 1,3-dioxane type material, and this is your major product. Clear? So this is the complete mechanism of Prins reaction. So firstly, attack with H plus, OH conversion, oxygen is positively charged, attract the bonding electron pair, so carbocation is generated. This carbocation is attacked by the alkene, so this intermediate form. Now this intermediate is responsible for two different mechanisms. If we add water molecule, then it is gives 1,3-diol. If we add more carbonyl group aldehyde or ketone, then it gives 1,3-dioxane. Clear? Okay, now let's move towards the application part. I am not going in the mechanism, that you have to do by yourself, so I am just directly giving the product. Suppose as a starting material I am using the benzaldehyde, and as an alkene I am using the ethene in presence of acid catalyst. So two product is formed. First one is 1,3-dioxane. So let me give its basic structure of 1,3-dioxane. So this is 1,3-dioxane. Now as we discussed that this two part comes from aldehyde group. So what is that part? So here is the benzene. So put simply here benzene, or we can say that pH, phenyl. Now this part comes from alkene. Now this part comes from alkene. Alkene containing CH2. So here CH2 as it is. So first product is this one, and the second product is 1,3-diol. Second product is 1,3-diol. So let me first put 1,3-diol here. So 1,3-diol. So this part comes from the aldehyde group. So I have to put here pH, right? So this part from the carbonyl group, and this part comes from the alkene. So here is the H. These two carbon, suppose this is star carbon and this is this carbon. So this is star carbon and this is the dollar carbon. Clear? This, suppose I am designating this carbon as hash. So this is this carbon. Clear? I am just giving this sign to differentiate the position of alkene and carbonyl compound. Clear? So you can write up the mechanism as we discussed in earlier, right? So now we are moving towards the second application part. Suppose I am taking the carbonyl group like this, phenoxyaldehyde. Suppose phenoxyaldehyde on react with this type material. It is also alkene, but I am just putting COO part over here. So two product is formed when we are going for the Prins reaction. First one is the 1,3-dioxane. So first write the basic structure of 1,3-dioxane. Now this two part comes from the carbonyl group. What is here? Carbonyl, this part. So just put this part over here, phenyl ring O और उसके साथ phenyl ring. Same here, phenyl ring उसके साथ O, उसके साथ phenyl ring. Now this part comes from the alkene part, right? So this two carbon is from alkene, this two carbon is from alkene. Now this two carbon attached with COOET part, COOET, and here COOET. So this is your major product. Clear? So this is the Prins reaction. Happy